we are going to be dealing with ambient noise control. Oftentimes we may refer to this as ANC, and sometimes even as automatic noise control, and we'll show you why that's an appropriate expression as well. We're going to look at some of the TOA products that have ambient noise control, and we'll look at the DPL2, which is our primary product, but we also have the AN001T module, which fits into our 9000 series amplifiers. We'll also look at the sensing microphones, the AN9001T microphone. To begin with, though, we want to define what ambient noise control does and what it stands for. As we said, we sometimes use the acronym ANC. But first of all, let's look at noise. Noise is any sound that's unwanted in an environment. It might be from the people in the environment, or it might be other sounds that are being pumped into the environment. And if it's at a level which interferes with or masks the intended program audio that we want to distribute into the environment, then we consider it to be noise. So we might be putting PA messages in there, or it might be background music that we want to have into the environment. We use noise sensing microphones and place them in strategic areas in the audience area so we can measure or sense the noise in the area. And these microphones then are connected back to the ANC device so that we can then record and measure how much noise is in the environment. As the noise level increases or decreases, then the program of the ANC device can also adjust the output volume to increase or decrease to compensate for that increased volume. The desired goal of all of this is to have your program noise louder than the ambient noise, but not so loud that it's going to be obtrusive. We can set minimums and maximum volumes to maintain predictable levels so that we know at what level the sound is going to increase when the noise increases. And we do that by setting gain ratios. If we look at the 3:3, that's an example of a gain ratio. It means that for every sensor change of 3 dB, so we sense that the noise has gone up 3 dB, then we increase the output volume by 3 dB, so that we're always above the background noise. Sometimes if it just did it automatically, a short burst of noise could cause your volume to increase rapidly. So we set sample times so that we can sample the background noise, anything from 10 seconds all the way up to 5 minutes, so that we can take the sample of the sound and then determine whether we're going to increase the sound or decrease the sound, or we're just going to leave it the same. Shorter sample times will make the system respond more rapidly. Longer sample times would make it respond slower. So why do we need it? Well, it helps to maintain comfortable listening level, but more importantly, if we're putting speech into the environment for paging, it maintains speech intelligibility. So you might have, for example, 10 dB above ambient, and you want to make sure that that stays constant. So as the background noise comes up, so your 10 dB for PA paging over ambient would be maintained. Or if it's background music, then you might set it at 3 dB for the background music, and that would maintain that level. Think about an environment where you would not have an ANC device. It might be a restaurant, and maybe you have a volume control to adjust the volume in the restaurant. Well, if someone is not paying attention to manually adjust that level, then it's going to be a hit and miss situation, as we have described here, because you hire people to run the restaurant not to stand by the volume control, but to do the job that they're hired for. And so this maintains that control automatically. And that's important because the background levels or the foreground levels that you're doing for music are adjusted according to the current ambient noise conditions. For example, if you start at a restaurant, or let's suppose a food court, that's a prime example. So they start up the program in the morning, they set the volume, then all of a sudden people come in. Well, there's more noise than they can hear the background music, but if they turn the volume up on the background music, let's suppose the coffee crowd, they come early, leave the area out of the food court, now the noise is too loud, the music is too loud. And so you have to go and adjust that. So this maintains the proper levels in the environment so they're always comfortably set. We mentioned a couple applications, but let's look at some of the broader applications, and that's for maintaining music audio levels and paging microphone levels. Typical background music would be your restaurants, your bars, nightclubs, and your retail stores. Conference rooms also could be grouped in there. An example of background music might be your restaurant, which you want to maintain the proper ambiance in the restaurant so the diners feel comfortable and not feel that the sound is too loud. But paging applications would also be important as well. Shopping centers, recreation centers. A good example of this is one of the theaters in Stratford, the Stratford Festival. In their lobby, they have an ambient noise controller so that when the crowds come out between acts to the bar, then they need to be able to tell them when the next act is going to start. And so they need to be able to adjust the volume or have the volume at the appropriate level so that regardless of how many people are in the lobby, they'll be able to hear the message and go back in to watch the show. Each zone then would have its own ambient noise control device and its own sensing microphone, such as that lobby at the Stratford Festival. So we can do single zone paging with the DPL2, and this is, as we said, our primary product that we use for broad range ambient noise control. And the unique feature about this is that it's able to distinguish the program output, in other words, what you are putting into the environment, from the ambient noise, or the noise that's already in the environment. And keep that in mind because the microphone will measure everything in the environment. This basically subtracts what you are putting in there, so that the measurement is more accurate. The automatic level control ensures that the source signals then are appropriate. So you can do an automatic level control so that regardless of what music you're putting in there, then it's going to be appropriate for your output. If you ever tried to re-record music onto a CD, for example, you know it's very difficult to get the exact same levels. And so this will help you to have those levels appropriate. We can set gating and threshold adjustment. For example, if you're doing paging and you have background music in the environment, you'd want to duck the background music down so that the paging would be clear and concise and would be able to be heard and understood. We also have an output for audio monitoring, so you can actually listen to or can record the ambient noise that is collected by the sensor microphones. And the microphones that we use are condenser microphones from TOA, but you could use dynamic microphones. And because we do use condenser microphones, then we're providing phantom power. This unit provides 15 volts of phantom power to operate those condenser microphones. You can set this system up either basic or advanced, and it's all set up by the front panel. We're going to deal a little bit with the setup, but we're not going to deal a lot with it because basically the setup is when you're actually in front of the unit, you need to know what to do and what buttons to push. And the manual is ideal for that. It's very detailed, it shows different scenarios, and tells you what buttons to push for what function. We'll look at the sensing microphones too. They are full range microphones, so you're going to pick up all the sound. You're not going to have a notched out sound or rolled off on one end. It's going to be full range microphone. And you can then adjust electronically the sensing characteristics. You can make it for normal noise level, or if you wanted to have it flat for loud noise levels, you can set that as well. Now let's look at some of the buttons on the front here. If you notice on the extreme left, the area that's outlined there, this is the sensor and input sensitivity adjustments that you can set on the unit. And so you can adjust those so that the system will operate appropriately. We look at the two buttons next to that. That's the programming button and the meter selection button, and we'll describe what those two shortly. We have an LCD screen that displays what you're doing, and you can scroll between functions by this parameter wheel, and you can scroll back and forth between different functions. And beside that wheel, there's two buttons there that allow you to advance or to go back in the programming. And then we have our input and output LED meters. So the lights there will show you what level the signal is, both for input and output. We also have input and output levels for the automatic level control and for the ambient noise control. And those meters are, again, LEDs, so that you can adjust them. And then we have the output maximum level control. Now, we don't want this unit to go like running amok, so you set a maximum so that you're not going to exceed your maximum level. And then on the back, of course, it's plugged into the electrical panel. And if you notice there is a ground point 2. Oftentimes you need to ground everything together to make sure the sound is harmonious. Some have asked about the RS-232 port at the back. Well, it's not used for programming. Some would like it to do that, but it's for future upgrades. So primarily we wouldn't be concerned with this at this point. But then you have your outputs 1 and 2, and you have your monitor output and your inputs 1 and 2. So you might have background music and you might have paging going into this unit. And of course you have one sensing microphone which would connect with its phantom power. So let's look at the sensing microphone. It's the AN9001 sensing microphone. It's omnidirectional, and as we mentioned before, it's a condenser microphone. And we use this microphone both for the DPL2 and for the AN001T. If you notice the design of it, it's a very flush mount design, very unobtrusive in a ceiling. It mounts directly into a single gang electrical box, so very convenient. The phantom power, as we mentioned, is supplied by the ANC device. And so we use two conductor shielded cable that wires from the microphone back to the ANC device. We can use multiple ones of these in an environment or different areas, and we can do that both with the DPL2 and the AN001T. And if we're using multiple ones for the DPL2, for example, in a common environment, then we'd want to put it through a mixer first because there's only one input from the DPL2 for the sensing microphone. So that would give you an average of the sound, and then you can deal with that ambient noise accordingly. So looking at the programming, we're only going to look at a few basic things, and this is actually the basic programming we're looking at. If you notice that you can make different adjustments. So if you look at the top there that's highlighted, you have the setting mode that you can adjust, and the little parameter wheel at the top can be rotated forward or reversed in order to do adjustments. You also see that on the next step there we have the summing mode, so you can actually sum the signal. We have the channel link, so you can link the channels together so that when one rises, the other rises, and when one decreases, the other decreases. So looking at some of the basic programming flow, you see that we move between different scenes by these buttons that are mentioned between the blocks. You can either go forward or backward to different scenes so that you can set it. And this is all done from the front panel, as we mentioned, on the DPL2. We also can make other adjustments, and as we mentioned, this is a basic programming flow that we're looking at. You can get into more advanced programming, but the manual deals with all of these, and I could walk you through each and every one of these steps, but unless you're sitting in front of an actual machine, it's not going to do a lot of good. But the manual, as I mentioned before, is very detailed. It'll walk you through each and every one of these and help you to be able to set them accordingly. So let's look at some applications for the DPL2. If we look at the top left, then we see that we have a microphone and we have two background music sources. So the first step that we do, we input these into a mixer, because the input of the DPL2 is line level only, except for the sensing microphone, which is microphone level. So the input has to go through a mixer for the microphone, and then you can combine different source sounds, such as background music, or it may even be you want to put in some store announcements, pre-recorded store announcements in there as well. So the mixer comes in very handy for a retail environment. And then it goes into the DPL2 signal, so there are two signal flows there. And the sensing microphone is connected, and then from the DPL2 it goes out to our amplifier and then to the different zones. If you look at the bottom part, without a microphone, then you do not need the mixer. You can go directly into the DPL2. Or over on the right side, we're looking at a transportation or an area with multiple zones. So again, you may want to use a microphone. You may want to do telephone paging into the different zones. So you would need a mixer, and then from the mixer into the DPL2. And for multiple zones like this, remember you can only have one microphone for each DPL2, so you might need to add more DPL2 units to the mix so that you can have control in various zones throughout the environment. And then each of those zones, or each of the outputs from the DPL2, then can go to an amplifier and feed the speakers in that zone. So you can build this up according to the number of zones that you need to control. We're going to look now at our other product, the AN001T, and that's designed to work with the 9000 series mixer amplifiers. So the mixer that we would use in this case would be the M9000M2. And look at some of the characteristics of this. It can control multiple zones. So each of the main frames of the 9000M2 can take two of the AN001Ts. Each AN001T then can connect to two sensing microphones. So basically you can control 4 zones by using one 9000 M2 series. One of the things that we want to keep in mind as well is that the AN001T is different than the DPL2 in that it's not able to distinguish program output from ambient noise. So in other words, it senses absolutely everything and measures it accordingly. And so the sensor microphones then obviously would be strategically placed so they wouldn't necessarily pick up the program music or paging that you are putting into the environment. So be very cautious of where you put those microphones. Again, the 9000 M2 has output for the sensing microphone, so you can listen to those separately. The 24-volt phantom power of the 9000 M2 then can provide the phantom power for the microphones. And you can monitor the levels, the maximum and minimum levels, and they can be set with the 9000. Again, sample times are set. In this case, we have different sample times, and they're similar to what the DPL2 has. Starts at 10 seconds up to 5 minutes, so you can sample at 10, 15, 20 seconds, 1, 2, 3, or 5 minutes. And the unique thing about this, it also has negative ratios for creating ambiance. You have 7 positive and 7 negative gain ratios, so remember the 3-to-3 that we had, so if the background noise rises by 3 dB, we're going to increase the output volume of 3 dB. So we have 7 different ratios that we can set to be able to deal with the background noise. And we also have the use of the DSP function of the 9000 that we can bring into the mix as well. So looking at how this works, we use the sensing microphones, as we mentioned before, and 2 of these can go into each module. Each module then fits in 1 slot, and we can put 2 of those in a frame. So 4 sensing microphones, you could zone or control 4 zones. The programming can be done by the front panel, like the DPL2, but a lot of people like to use the computer program to log on to the machine and then to be able to set the programming on your computer and do your adjustments that way. So if you see, as we have populated the frame, we have 2 modules in there. We've got a D001T, and then we've got the AC9001. So we've got an input module that'll take 2 zones, and we've got a sensing module that can also have 2 microphones for those 2 zones. And so now we want to set those up, so you could click on the appropriate button there and then go to the setup for the AN9001, and it gives you ways of setting this up. And it's very simple. You can use the front panel as we mentioned, or you can use this basic programming module. And if you look at all the things you can set your levels. For example, the ANC level can be set, and it has a pull-down menu. So you scroll down to the level you want to set it, and click on that, and it'll set it. And so you move down to the next level, and again another pull-down menu. So you can set all your levels all the way down throughout the whole program, and even set your ANC reference levels. And so you see, it's very simple with the programming in the 9000 unit. And even your output levels you can set. And so looking at some applications for the AN001T, for the ambient noise control, If you notice that we have one box, it's the mixer amplifier, and we have two zones operating directly off of the mixer amplifier, and two, we have a separate amplifier to be able to control two more zones. So two modules in the frame, which will allow us to have 4 sensing microphones. And this is a multi-zone environment we have. As we mentioned about the DPL2, you can build up the number of DPL2s so you can have multiple zones as well. You could also theoretically build up the number of 9000 series with modules in them to control many more than 4 zones. So we have the first multi-zone area. You may just have a restaurant or bar area and it might only be 2 zones you're controlling. Maybe the bar, and you need to have the sound there at an appropriate level when it's quiet or when there's a game on and when people are starting to talk about what the plays were, etc. So you want the sound to come back up for those who want to listen to the program. And for the restaurant, the dining area as well, you want to control the sound there because when you have only 3 or 4 people in the room, not a lot of noise, but as the room fills up and you get 40, 50, 60 people or so, then you have a lot of noise in the environment. So then it'll bring the background music up to an appropriate level. So in conclusion, the ANC is used when the program content, such as the background music or the paging, needs to be louder than the ambient noise. And usually that's the case. It's appropriate to have this and very convenient when you don't want to have someone stand by the volume control all day long and just to adjust the sound. The unit helps to maintain speech intelligibility because you can set the level that you want for so many dB over ambient and it'll maintain that as the sound goes up and down, as the noise goes up and down in the environment, it'll adjust the output volume. For critical applications where you need to have precise measurement, then the DPL2, you can have unlimited zones, as we mentioned, by putting multiple units into the rack and then wiring the microphones to them. For other applications, the AN001T and the 9000M2 can be used. Each of these boxes can control a maximum of 4 zones per system.